So most of everything we've been talking about with all those functional areas, where all those sensory and motor stuff was happening in the cortex, right? That outer layer over here. We talked a little bit about those limbic structures that were around here that were really kind of these deep infolds and other weird kind of non-anatomically discrete structures. But then the other major part of your cerebrum are these basal nuclei, right? That's part of the cerebrum. And there's these clusters of neurons that have a particular input and output. Their function is super complicated. And we're just going to go over very basic ideas of it and then look at the cerebellum, which has kind of similar, but a little different functions because they're both related to movement. What it's all about is movement, right? And it's about initiation and turbulent of complex movements in a way that's best understood by looking at what happens when things go wrong here, right? So your basal nuclei, is receiving input from your cerebellum and your other motor cortex areas to kind of control gross motor movement output in some barely understandable way, right? That would be your basal nuclei, and your cerebellum is going to be assisting in that movement function. So I put this here. This is from the Powerpuff Girls. This was like, her name was like Cerebellum over here. But if you look at her, the whole structure of her, right, you can see that she was modeled actually after the cerebellum. Isn't that cute? In any case, the cerebellum, for its functions, basically what you want to know is that it's adjusting the postural muscles at any given moment because it is getting in proprioceptor sensory information, all those spindle fibers and Golgi tendon things that tell you what your position and the tautness of your limbs are, which gives you a body information sense. And it's also going to get input from your vestibular organ, right, about balance and equilibrium. And it's going to fine adjust on stuff like that, right? So this is both programming and fine-tuning movements as you do complex activities. So, when you learn to ride a bike, your cerebellum is help you learn it, make it easier next time. So you do all these sort of unconscious fine tunings as you do the action right there, right? So, when you look at the cerebellum, you're going to see the cortex area here, just like your cerebrum. You're going to have white matter underneath here. In particular, it's called the arbor vitae. That's the white matter tracts that have this kind of tree-like structure. You'll see that on the cadaver ones. You'll also have a little bit of cerebellar nuclei that are doing some stuff, right? So it's kind of like, that's why they call it the little brain. A lot of neurons, very complex stuff. And then you have the input and output to it. And these will be the peduncles. I don't know why they named it, but they're the peduncles, the cerebellar peduncles. These are white matter tracts, big tracts of myelinated axons coming into and out of the axons. Right? So your input to your cerebellum is going to be from your inferior peduncle, and that's going to be from your inner ear, right? Your equilibrium things of that of your semicircular canals, and then all those proprioceptors, your stretch and Golgi tendons, right, coming in, and they're going to enter your cerebellum with that information. Tell your cerebellum what your body's doing at any given point. It's positional information. You also, from your cortex, you're sending down information about planned movements, right? And your cortex wants to check with your cerebellum. So there'll be a branch coming from that, from your middle peduncle. So these two, your planned movements as well as your current situation, is the input to the cerebellum, right? So now it knows what the body's doing, it knows what your body wants to do, and it's going to give the brain some feedback about that through your superior peduncles. It'll be the output from the cerebellum to the cerebrum, right? And so once it gets that feedback, your motor cortex can adjust a little bit, right? It was about to do this action, but your cerebellum told them, no, I was a little bit out of balance. I was standing on one leg on a ledge. Don't do that, something like that. And that's basically the general function of this, like taking in body information and kind of fine tune adjusting your particular movements. All right, so damage to the cerebellum, the easiest way to think about it is if you've ever seen somebody who's really drunk and they're stumbling around, they can't, like, if they close their eyes and they try to touch their finger to their nose, they miss or something, right? That is ataxia, cerebellar ataxia. And it's something that when you have a loss of that, you basically lose coordination. So coordination is one of those key words when you're thinking about cerebellum. Coordination, kind of whole body coordination. And so when we think about these two things, I didn't really explain basal nuclei because it's really complicated too much, but it has to do something with movement. And I'll talk about it a little bit more because we talk about a structure in the brainstem that's related to it and related to Parkinson's disease. But basically what you see with Parkinson's disease is a loss of function of basal nuclei. And what the effect of that is they are very slow to initiate movements. And then when they do, maybe they are very jerky in it, right? So if you've ever seen someone with Parkinson's, right, this is kind of a function of the basal nuclei disorder, an underactive basal nuclei. And that's because we'll talk about why it is when we talk about the brainstem. But then the other thing which I skipped over was other things, disorders that was a loss of function of your basal nuclei. There's also things like overactive basal nuclei, and that'll make you very compulsive, right? So higher order behavior, right? Chronic anxiety, Tourette's syndrome, right? Very impulsive kind of behavior, things where you can't control, like twitches and spasms and stuff like that, or uncontrolled behavior. That's an overactive basal nuclei. And both of them have to do with dopamine because your basal nuclei are kind of modulated by the neurotransmitter dopamine. In any case, that is the end of that brain stuff. Next time we'll talk about this part of the brain, right? Just not the thalamus here, but the brainstem, right? Because this will tie into stuff about your autonomic nervous system. And then we'll talk also about your cranial nerves.